Once again, good morning, ladies and gentlemen. We are now on problems involving equivalent fractions. Okay, first, let's take this example number 1. The given fractions 5 over 16 and x over 12 are equivalent fractions. Then find the value of x. So in this case, one of the equivalent fractions has an unknown x. Okay, for our solution, we are going to use the ratio and proportion way of solving this problem. Okay, so we have here 5 over 16 is equal to x over 12. Okay, so by cross product method, the 12 can be multiplied to the numerator which is 5, so that becomes 5 times 12. As you can see in this example, we are using parentheses as a grouping symbol, which also implies multiplication. We don't use x or times as a symbol for multiplication. It's because we might have some confusion with the variable x. So instead, we are going to use parentheses for this particular example. And as the case also applies to higher math beyond arithmetic. Okay, so we have now 5 times 12 by cross product, by concept of ratio and proportion. So over 16. Okay, so that is equal to x. Okay, so we can also rearrange if we would like, but anyway, they mean the same thing. So rearrange, we place the x on the other side, which is on the left side of the equation. So then our 5 times 12 divided by or over 16 is on the other side, which is on the right side. Now by operations here, so we can multiply 5 by 12, or we can do the cancellation process. The cancellation process helps us to lighten the burden of calculations. Okay, how does it helps? Okay, so instead of multiplying 5 times 12, which is equal to 60, we are going to factor 12 as being compared to 16. We'll find their GCF, or the greatest common factor. So the greatest common factor of 12 and 16 is 4. Okay, so instead of writing 12, we are going to write that as 3 times 4. Okay, and then 16 can be written as 4 times 4. Okay, So from here, you can just cancel numbers common to the numerator and the denominator. Okay, so 4 over 4 is equivalent to 1. Okay, we have already eliminated 4 on the numerator and the denominator. So what we are focusing now is 5 times 3. So 5 times 3 is 15. Okay, so over 4. So meaning the value of x is 15 over 4. So we are going to substitute this or replace this value of x into the original equation. Okay, let's see. Okay, so five over 16 is equal to x. Okay. Later we are going to replace that x by the value we have found here. So 5 over 16, x is 15 over 4 divided by 12. Okay, it's a bit complicated, a fraction within a fraction, but we are going to do this bit by bit so that we will understand how to solve this problem. Okay, so 5 over 16 on the left side of the equation. So we are going to apply the rules in dividing fractions. Okay, so in dividing fractions, we are going to apply the flip and multiply. Okay, so meaning the 15 over 4 will be multiplied to the reciprocal of the denominator, which is 12. The reciprocal of 12 is 1 over 12. Okay, 1 over 12. So the equation will look like this. So 15 times 1, that is. Okay, but before that, we can simplify this. We can cancel before multiplying 4 by 12, because we see that 15 and 12 has a common factor. Both of them has a greatest common factor of 3. Okay, I hope you see that. So we are going to cancel before multiplying. Why? Because it will help us to lighten the burden of computation. Instead of computing large numbers through cancellation, we can eliminate the common factors and multiply a bit easier or real numbers that we are going to deal with ease. Okay, so 15 has 3 and 12 has 3. So if you're going to cancel the 3, 15 has 5. Okay, 12 has 4. So the 3 within the 15, the factor 3, because 15 is 3 times 5 and 12 is 3 times 4, the 3 of 5 and 12 are being cancelled. So what's left for 15 is a factor of 5, and for 12 after cancelling 3 is 4. Now the equation will look like this after cancellation. So instead of 15, we write 5 times 1. Okay, over 4 times, instead of 12, we have here 4. Okay, so as you can see, 5 times 1 is 5, and 4 times 4 is equal to 16. It only shows that after substituting or replacing the value of x, which is 15 over 4, the equation becomes true. Why true? Because it balances after substituting the value of x. So therefore, the value of x we are looking for in this example is 15 over 4. And that 15 over 4, if we are going to simplify or write this in mixed form or mixed number, that is equal to 3. 3 times 4 is 12. So 15 minus 12 is 3. So we have a remainder of 3. So we have 3 and 3 4. To check, 3 times 4, 12, plus 3 is 15. So 15 over 4. So therefore, the value of x is 15 over 4, or 3 and 3/4. Okay, so another example below. Example number 2. Two fractions 3/5 and 4 over x are equivalent. Okay, now find the value of x. Since they are equivalent, we are going to use the concept of ratio and proportion. We're going to illustrate this in an equation form. So we have here 3/5 equals 4 over x. Okay, so we're looking for that x. So x is a variable, meaning this is a letter or a symbol that only represent a certain number that will satisfy this equation to become true. Okay, so we can replace x by any letter or symbol we would like, but this particular example uses this letter or symbol. Okay, so by cross product method, so we are going to interchange the place of 3 and x, because it would be easier if x is on the numerator. Okay, so replace the position of 3 in x. So x is equal to 4 over the 3 going to the position of x. So that's over 3. And since we are going to solve for x, we have to eliminate, or we have to set aside x. By putting aside x, we are going to transfer this 5 to the other side of the equation by cross product method. Okay, instead of writing 5 here below x, that will go through in or adjacent to 4. So meaning it becomes 4 times 5. Okay, so let's see if we can cancel here. So 5 and 3 has no common factors because they are both prime. Although 4 is a composite number, but comparing 4 into 3, they have no common factor. So we are going to directly multiply. Okay, that's 4 times 5, 20, okay, over 3. So we can get the equivalent mixed form or mixed number of this. So 3 times 6 is 18, so we place here 6, and 20 minus 18 is 2, all over or over 3. So by checking, 3 times 6 is 18 plus 2 is 20. It's 20 over 3. So therefore, the value of x in this particular example is 20 over 3, or a mixed form or a mixed number of 6 and 2/3. Okay, to show that this is correct, we are going to substitute the value of x in the original equation. So 3/5 is equal to 4 over x. Instead of writing x here, we are going to use this improper fraction instead of this mixed form, because the improper fraction is much easier and more direct in substituting the original equation. So we have here 20 over 3 as the value of x we have found. Then by calculation, 3 over 5, on the right side of the equation, we are going to apply the low and dividing fraction. So the flip and multiply. So since the numerator is 4, so write 4 here. And multiply to the reciprocal of the denominator, 20 over 3. The reciprocal of this is 3 over 20. Now before multiplying, let's see if we can cancel. Okay, so here we see that 4 and 20 has a GCF, or a greatest common factor. Take note that 4 as a whole number is understood to be a numerator having a denominator of 1. Okay, so 4 and 20 has a GCF of 4. Meaning if we are going to divide 4 by 4, that's 1, and 20 divide 4 is 5. Or the factor of 4 is 4 times 1. The factor of 20 is 5 times 4. So we take the 4 common factor to both. So 1 times 4 becomes 1. The 5 times 4 becomes 5. Okay. Now we can continue in computing this equation. So we have here 1 times 3 is 3, and over 5. As you can see, our equation is balanced or correct. When the equation is balanced or correct, we can say that the value of x we have solved is correct. Okay. Now going to example number 3. Example number 3. What fractions are the same as 1/4? Okay. So in this case, we are going to list some of the fractions that are the same as 1/4. But we cannot write all of them because there is an infinite number of fractions that are the same as 1/4. What we are going to do is, by starting here at 1/4, we can we can multiply it by 3, the numerator and the denominator. Okay, so 1/4, both the numerator and denominator multiplied to the same number, let's say 2. So that entails 1 times 2 is 2, 2 times 4 is 8. Okay, so 1/4 is equal to 8. What else? Again, from 1/4, we can multiply that by common common number. Multiply the numerator and the denominator to the same number. So let's say 3. So 1 times 3 is 3. 4 times 3 is 12. So another fraction that is the same as 1/4 is 3 over 12. Okay. Now continuing with this concept, so by iteration, okay, doing the same process, only differs in the number that we are going to multiply to the denominator and numerator, or numerator and denominator. So from 2 we go to 3. So as you can see, the sequence of numbers is here. So follows 4, and that is equal to 4 over 16. Now another number that is equal to 1/4 is 4 over 16. Now to continue once more, so 1/4 multiplied to the same number, the numerator and denominator, so it follows that 5 here after using 4, so that becomes 5 over 20. And the iteration process can be endless. Okay, endless. So what we have here are only few of the numbers or fractions that are the same as 1/4. So the last that we have is 5 over 20. So we have answered the question, what fractions are the same as 1/4? So 1/4 is the same as 2/8, as the same as 3 over 12, as the same as 4 over 16, and 5 over 20, and so on up to infinity. Okay. Okay, I think we have here another example, the last one. So example number 4. What is the fourth equivalent fraction of 3/4? Okay, so following the same procedure as example number 3, so our 3/4 can be multiplied to a number, to the same number, to both the numerator and denominator. We will not use 1 because 1 will not change the value of 3/4. Instead, we are going to use 2. Okay, so that is equal to 6, and 4 times 2 is equal to 8. Okay, so 3/4 is equal to 6 over 8. Okay, continue. 3/4 is equal. Okay, so we will use 3. Okay, 3 times 3 is 9. This is 12. Okay, so we have here 9 over 12. And continuing up to the third equivalent fraction, so 3/4. So 3/4 multiplied to the same number, both the numerator and denominator. So in this case, 4. So 3 times 4, that's 12. And this is 16. 4 times 4. So it's equal to the third fraction, which is 12 over 16. And we are looking for the fourth, okay? For the fourth fraction that is equal to or the same as 3/4. Okay, 3/4. Okay, multiplied to 5. Okay, 5. So that is 15 over 20. Okay, so 15 over 20 is the fourth equivalent fraction of 3/4. So the first equivalent fraction is 6 over 8. Second is the 9 over 12. The third equivalent fraction of 3/4 is 12 over 16. And the fourth equivalent fraction of 3/4 is 15 over 20. Okay. So that's how we get this fourth equivalent fraction of 3/4. Okay, I hope that sounds clear.